Hello everyone, my name is Sizhong Xu. I'm the professor and the chair. Welcome to Professional Service Centers of the Department of Civil and Construction Engineering at the Chaoyang University of Technology. The department has three service centers. They are Center for Non-Destructive Testing, the Building Information Modeling Center, and the Technical Service Center. The director of Center for Non-Destructive Testing is Professor Zheng Jiaqi. She has received her PhD degree from Cornell University. The director of BIM Center is Professor Wang Kunqi. He has received his PhD degree from National Jiaotong University. The director of Technical Service Center is Professor Cai Peixun. He has received his PhD from Chenggong University. He is also a professional engineer. The following presentation will be carried by these three directors.
My name is Chachi Chen. I am the Director of Research Center for NDT in Chaoyang University of Technology. Contents of this presentation are mission statement, general information for RCNDT, and current activities, which includes services and collaborations, ongoing research projects, education, and international cooperation and exchange. The mission statement. There are two missions for our center. The first one is advance the research and promote the applications of non-destructive testing technologies. The second one is education, which refer to the NDT Enterprise Program. General information. First, I would like to talk about the history and the revenue. The Chaoyang University of Technology was founded at 1994. Because there are several professors in our department have specialties related to civil NDT. We start the Center for NDT at 2005. At 2014, the name of the center changed to Research Center for NDT because it becomes one of the research centers supported by the university. The annual commissioned budget averaged 10 million NT dollars for recent years. The projects conducted by our center include testing targets of tunnel, embankment, bridge, reservoir, building, pier, nuclear power station, wind turbine, highway, and airport. So they are very versatile. There are 7 main researchers in our center. Professor Chen, Professor Shi, and Professor Chang. Their specialties are in structural NDT and structural health monitoring. Professor Cai, Professor Xu, and Professor Lai. Their specialties are in geotechnical NDT. And Professor Huang, whose specialty is in remote sensing applied to NDT and image processing techniques. For the staff and the students in our center, there are 3 postdoctoral researchers. One is an international postdoctor from India. And there are 5 full-time staffs, 10 full-time master students, and 1 PhD student. And there are 6 undergraduate students supported by affiliated projects. The third part is the current activities. I will talk about the major services and collaboration. Select several ongoing research projects to talk about and NDT Enterprise Program for undergraduates. Finally, I will talk about the international cooperation and exchange. The first services and collaborations I would like to talk about using ground penetration radar to detect hollows in the embankment or the pipelines underneath the road. Those are the major service fields in our center. We have more than 100 kilometers of embankment ground penetration radar testing experience. An instrument called EBIS, which is a step frequency microwave interferometer used for bridge monitoring. EBIS can simultaneously measure the dynamic displacement of multiple points on the bridge deck. The accuracy is 0.1 mm to 0.01 mm, and the data acquisition frequency can up to 200 Hz. So, if we monitor the vertical displacement of normal traffic for 20 minutes, the bridge model frequency and the mode shape can be obtained. We use multiple methods for tunnel assessment. We use the ground penetration radar to assess voids beneath concrete lining and use LiDAR scanned for monitor the tunnel deformation. Using the dynamic photography and the LiDAR scanned data to create the unfolded view of the anomalies in the tunnel. For the wind turbine structural safety assessment and monitoring, two non-contact monitoring methods were applied. We use UAV carrying infrared camera and a regular camera to fly around to visually inspect damages on pilot and arbor. And we use the microwave interferometer to also place under a pillar to check the mode shape and the vibration mode frequency of the pillar. I would like to introduce two innovative stress wave methods developed in our center to assess the debonding at steel-concrete interface. For the cases such as concrete-filled steel tube damaged by fire and not fully filled of epoxy resin for the factory floor strengthening by steel plate or the weir strengthened by steel plate. One method is to place the small hammer impactor away from the receiver to obtain the lambda wave model vibration and use the difference of A0 model dispersion curve of the steel plate to assess the debonding. The second one is to place the hammer close to the receiver and using the amplitude of the peak in the normalized amplitude spectrum to examine the voids underneath the steel plate. Conducted many cases of monitoring replacement of bridge bearing pad during jacking up the bridge girder. Worth to mention is that wireless transmission routers were applied to transmit signals of the displacement sensors to the computer so that the monitoring become quite easy without connecting large number of electric wires. For the ongoing research projects, first is the project funded by the Ministry of Science and Technology. In the project, we assessed the depth of the damage for the reinforced concrete after fire using the dispersive characteristic of rally wave group velocity. We use one impacting hammer and a displacement receiver or a microphone to obtain the rally wave, and use short-time Fourier transformation and reassign method to obtain the dispersive curve. And after the proper inversion process, we can get the velocity profile with respect to depth. So the depth of the damage depth after fire can be assessed. Second project is funded by National Chongshan Institute of Science and Technology, using the AI deep learning on the ground penetration radar imaging recognition for embankment assessment. Ongoing research project is to apply digital image correlation (DIC) to monitor wind turbine pillar. The preliminary research was conducted in lab using 2 digital cameras to measure the 3D movement of a pillar with multiple marks and multiple defects, using the modal difference index to identify the severity and the location of the defects. Education. Our centers support junior and senior year projects, also the NDT Enterprise program, which has 15 credit hours. In the program, the students can learn how to operate NDT instruments. Also, they need to take the designated courses related to non-destructive testing and financial management. Currently, about 130 students enrolled in this program. For the international cooperation, Professor Chia-Chi Chen and Ken Chang-Shi cooperate with Professor Yi-Ching Ni of Hong Kong Polytechnic University for the project to assess the delaminated cracks in cement asphalt mortar layer of high-speed rail tracks in China using normalized impact echo method. So we went to Hong Kong Polytechnic University to conduct experiments, and Professor Chia-Chi Chen offered a seminar with the group in Hong Kong Polytechnic University. Also, we have published one SCI journal paper and attend a conference at Stanford University and publish one conference paper. The International Non-Destructive Testing Laboratory Exchange. Professor Chi Hong Chiang represented CYUT Center for NDT, participate at annual meeting of World Federation of NDT Centers. The meeting was held at Minneapolis, USA, and the date is 2015. Recent 5 years, we published about 10 journal papers each year, and also several conference papers. So we welcome scholars from all over the world to visit us, and also the students who are interested in non-destructive testing are welcome to apply for master's or the doctoral programs. Please contact Professor Chia-Chi Chen. My email is ccccheng@cyut.edu.tw. For listening and welcome to visit.
Hi everyone, I'm going to introduce the Research Center for BIM Application and Innovation we call BIM Center below. It's a research center of Department of Civil and Construction Engineering. First, we want to introduce our goals and members and all about us. The main purpose of establishing BIM Center is to train students as BIM professionals. In addition, the BIM Center also develops practical technology and research innovation. This is the organizational structure of the BIM Center, headed by Dr. Chaoyang from Department of Civil and Construction Engineering, including 4 doctors as executive committee and expert consultant of the BIM Center. Also, we have students as the part-time research assistant. Okay, now we move to the implementation policy. The BIM Center has 3 main implementation policies, namely BIM-related industry-university cooperation projects, academic research, and BIM personnel training. First part is industry-university cooperation. The service we provide includes BIM model establishment, quantity takeoffs, virtual reality-based interactive education system for construction hazards, BIM and VR-based cost estimation system. The details will be introduced below. By cooperating with the industry, students can learn the skills of BIM-related software. Also, they learn the requirements of the practice. This is a case about BIM model establishment. The general contractor used the BIM model to detect the clash and discuss the details of the building, like the tiles, like the shafted roof. What is more important is the integration of the electromechanical model and the structural model. It is because the electromechanical engineering is more complicated than structural engineering in practice. So the BIM model, all parties can understand in advance how to arrange the electromechanical pipelines. In addition to viewing 3D models, BIM model can also be used for quantity takeoffs. The calculation result can assist the owner or the general contractor to evaluate the project budget quickly. And the 3D animation is also an important function of BIM. It can show the expected view and environment, and this can help the owner or the customer foresee the building before completion. Here we have a video showing the 3D animation made from the BIM model. Okay, it's a video. We made it by the BIM model. By the 3D animation, it can also facilitate the space planning. It's a case in the campus. We use BIM model to facilitate them planning the campus space. Okay, in addition to BIM, our center is also actively developing VR-related technologies. We developed a VR-based interactive education system for construction hazards. By using this system, laborers in the construction site can learn the hazard knowledge with a realistic scene. It's a part of the system to show the VR environment. We can see the video below to learn more. It's an important part, and now we move to the second part, academic research. Other researches are BIM and VR related. We'll introduce some of them below. It's about integrating BIM and 3D printing. We try to transform BIM model to a 3D printing model. When we print the virtual model out, the laborers can discuss how the facilities can be assembled. so it can facilitate the construction process. Also, we develop a BIM and VR-based cost estimation system. When a change order occurs in a construction project, we usually need almost 2 weeks to estimate the cost of change order. By using this system, customers can see the changes in the VR environment directly, so that the customers can know if the changes meet his requirement or not. When the change is done, cost of the changes can be calculated automatically, so it can save lots of time. In the study of 5D simulation based on BIM and VR, a cost of schedule management model is developed. First, a BIM model is linked with the schedule activities to simulate the construction process. Then integrate the cost item into the 4D simulation to develop the progress curve. In addition, this research further presents the model in the VR environment. Third part of the BIM Center's work is the most important part, personnel training. We have several BIM-related classes in our department, including basic classes and advanced classes. Basic classes are for the model establishment, and the advanced courses are for BIM applications. It's a teaching overview of our courses. About 6 students take the BIM courses every year. The photo is about they are taking the exam, the final exam. It is because all of them need to build their own models. Everyone need to have a complete model by themselves, and then they should display their models by using the animation software. Also, students need to build the electromechanical models and understand the interrelationship of the electromechanic system, and then integrate the electromechanical system and the structure. Also, students use the Cubicost quantity takeoff software. They build a BIM model and then do the quantity takeoff to calculate the cost of the model of the building. It's all about BIM Center in Department of Civil and Construction Engineering. Thank you for your time and attention.
Welcome. This is Technical Service Center. The Center for Professional Service was established as an affiliated unit with technical supports from the faculty members of Department of Construction Engineering. In addition to provide a central laboratory and field tests for the teaching programs of the department, the center also serves as liaison as a platform of performing engineering consultants, which is open to the general public in Taiwan. Technical Service Center. We have laboratory tests, field tests, commission research and consultancy, structural design review, education training. The department now has the following laboratories: Materials Lab, Geotechnical Lab, and Structural Lab. Material test items. Now we're doing concrete space compressive stress tests, cement mortar compressive stress tests, Chaoyang contact test in concrete, concrete mix design, cement and aggregate property analysis, steel tensile test, steel radiation detection, steel stabilizer resistance tensile test, asphalt mixture ratio design and test, and you see that all the other items. Material laboratory equipment. Now we have universal testing machines. We got 200 tons and 50 tons, elemental chamber, ultrasonic tester, concrete core machine, premier concrete tester, concrete creep tester, radiation detector, Chaoyang contact of analyzer, computer automatic control system. Now introduce our universal testing machine. Our 200 tiles and 50 tiles. Universal testing machine is a machine that allows samples to be tested in pure tension or pure compression. The universal machine united in the materials lab have several different couples that allow different types of loading conditions. Aeromental chamber. The aeromental chamber is a capable of controlling temperature as well as humidity. It has the temperature range of -4 to 212 degrees Fahrenheit, with a temperature constancy of ±0.5 degrees Fahrenheit. The chamber also has a humidity range of 10 to 95%, depending on ambient temperature and humidity with accuracy of ±2.5%. Now talk about our geotechnical service. We have material property test of soils, in situ monitoring of slab and retaining structures, bearing capacity evaluation of foundations, geological investigation using seismic wave techniques, ground improvement evaluation, integrity test of piles, liquefaction potential evaluation. This is dial shear test equipment. A dial shear test is a laboratory test used by geotechnical engineers to measure the shear strength property of soil. Triaxial compress test. Triaxial test of soil is widely used in geotechnical engineering. Specimens are actually loading to failure while a confining pressure is constantly applied. As a result, the behavior of geomaterials is investigation in the three-dimensional straight state. This is pressure plate apparatus. Pressure plate test is used to obtain the soil water characteristic curve of unstructured soil. The Brazilian test. The Brazilian test is a laboratory test conducted in rock mechanics to indirectly determine the tensile strength of rocks. Ground resistivity test equipment. Ground resistivity test is a process of measuring electrical resistivity of soil to determine the conductivity of the soil. Multi-channel analysis of surface wave test. It measures the shear wave velocity distribution in depth. Thereby can be used to measure the agreement of overburden and bedrock. This is pile integrity test equipment. The pile integrity test reveals potential shaft or pile defects such as major cracks, necking, soil inclusion, or void. This is prototype debris flow simulator. It simulates and studies the effect of various prevention facilities on the debris flow. This is safety monitoring of slab and buildings. The first picture right here is in kilometer. Monitor the changes in horizontal displacement distribution of the slope. And the second meter is tile meter. Monitor the changes in the inclination of the struggle. Now introduce our struggle laboratory. Our struggle laboratory is equipped with a 20 meter by 10 meter by 7 center reaction slab and an 8 meter, 7.2 meter, 1 meter reaction wall, which provides the vertical and horizontal loading reaction supports for the large-scale struggle load test. The floating crane system with 40 meter clean height and a 20 tiles capacity is also equipped with transporting large space. This is our surface item of our struggle laboratory. We're doing loading capacity of scaffolding system. Load test for small scope struggle element. Load test for large scale struggle element. Load test for various types of construction material. Vibration monitoring of struggles. Overall safety evaluation and inspection of struggles. Consulting service of special struggle design and construction. As you can see, this is our 135 tiles, 4.5 meter clean height scaffold loading system. Here's the scaffold loading test video. You can watch right here. The vertical bar in the lower right corner will buckle. Okay, the bug out happened right here. Now, this one is our 50 times MTS load frame for material testing. And this one is 50 times MTS actual for struggle test. Right here. Okay. Now, let's see the video of lightweight steel frame load test by using our 50 times MTS. Now the pressure coming to the 20 tons. Yeah, you can see. Yeah, the buckle right here. Okay, the breakdown. Now this one is our one-way small scope scaping table, and this video is a building seismic resistance test. It's a competition to design earthquake resistant model buildings. Now, doing the correct. And now go 3, 2, 1. Start it. You only go one way, to left to the right, left to the right. Now go to the end. Now it's shaking a lot. Okay, it break one in the behind, and this one also break down, and this one is still safe. Okay. Now introduce leader, light detection and ranging. Leader is a method determined by targeting an object with a laser and measuring the time for the reflect light to return to the receiver. Leader can be used to make digital 3D representation of area on the Earth's surface, due to difference in laser return times, and by every laser wavelength. This is our computer classroom. We got 67 PCs and digital broadcast teaching system. Here are our software installed in our computer classroom. We got Nestron, ETAPS, SEP 2000, Flag 2D, Flag 3D, TOSA, Stairwind, Redoplex, and also AutoCAD Project, TOCA, and BIM. Now this one is Flag 3D, Group Anchor Pull-Out Test Simulation. It can detect the pulling force that the group anchor can provide. Now you see the first one, this one is Stairwind. It can calculating the safety of the slope based on the limited equilibrium method. And the second one, this one, is TOSA. It's about wall stability analysis of the excavation.
Okay, now I make a brief conclusion. These three centers and their members has contributed tremendously to the development of our department. Therefore, academia, industry collaboration, and the government funding both support the faculty members and the students to publish their researches on the well-known journals. You are welcome to join us whenever you want. Scholars are welcome to visit our department, and the students to apply for master's and doctoral programs. Please contact me, Professor and Chair Shi Zhongxu. Thank you.